Right, so today we are starting sequences. The book jumps into a whole bunch of stuff. So I have a whole day of just intro to arithmetic sequences for you today, and tomorrow geometric. We need to talk about what arithmetic sequence means, okay? So an arithmetic sequence means you are adding something every time. Could be a positive or negative number, but you're not multiplying by something, you're adding something. Yes, he's here, Tristan. It is a sequence that, if graphed, would go up consistently. So you'd have a first term, second term, third term, fourth term. So it's basically linear because it's increasing by a certain amount, okay? So there are fancy ways of writing this. First, let's just put an example down. So say we started at 7 and decided to add 3. We'd have, how did I do? Does that seem right? Okay, so the notation would say a sequence whose first term is 7. Okay, so this means first term. Oh, can't spell. So this notation, a sub 1, means first term. So if I had a sub 5, it would mean I wanted the fifth term. Fifth, F-I-F-T-H, right? I'm really struggling today. Everybody good with that notation? What that means now, the little subscript is a lower, instead of an exponent, it's a subscript. All right. Go ahead. No, they usually use A or U, I think. What does the worksheet use? I know there's some on here. They use A here, okay? But sometimes they do use U sub n. That's a good question. And it doesn't matter if it's arithmetic or geometric, they're still going to use the same letters. It's not like A is for arithmetic, okay? So the definition, if we want to write a definition in our own words, what could we say? What makes this arithmetic? What are we doing? Yeah. Oh, kind of ran those words together. Sorry. But does that, you can put it in your own words, but you start somewhere and you're adding a constant amount to each previous term. Does that seem okay? So there are two ways we can write a definition. Okay. We started this a sub 1 is 7, but to get to the next term, you would say a sub anything is the previous term plus 3. All right, so I need to check something here. I'm kind of confused. Do I have, oh, I do have this already. I should wait. All right, so that's the definition of this one, but let me explain it a little better in a second here. All right, so our learning targets today, decide if it's arithmetic and find the difference, write an explicit and recursive, and I'm going to define those in a second, and given a specific term, find another term. So an explicit form is when you say n equals the term number, and you have a definition that looks like a sub n equals, how would you tell me to find like the fifth term? Does anybody know? What would you start with? The first term, right? And how did we define first term? Yes. And then because it's arithmetic, we're adding, right? That the difference between the terms is just called D. And if I want the fifth term, am I going to? Yeah, absolutely. If I want the fifth term, do I add that difference 5 times? Okay. So if I want the fifth term, 1, 2, 3, 4, fifth term, and the difference was 3, how many times did I add the difference to get the fifth term? 4, right? I only had to add, I added it once to get the second term, 2, 3, 4. So the idea for this is that you add the difference one less time, so it's n minus 1. So let's talk about what all those stand for. This is any term, like if it was a sub 7, it would mean the 7th term. The words for this are what? What's a sub 1 mean? First term. D is difference. I'm going to just write the common difference so you understand what we're talking about. And N is the term number, and then you subtract 1. So my example at the top of the page, I'll write it again. Did we start with 7 and we were adding 3?
Yeah.
Can we find the 53rd term? How would we do that? It would be the first term, which was 7, plus what is the difference? Positive 3. And how many times would we need to add positive 3?
2.
53 minus 1, or 52 times. And it's okay to write 53 minus 1 if that helps you understand where that came from. What is that? 156 plus 7, 163 maybe? Okay. So an explicit form is based on the term number, okay? Whenever it says explicit form of an equation, it means it's based on the term number n. Okay, it has to have an n in it. We good? All right, so this is about defining the notation, so we can go on and do all these. A recursive form is when you write the equation based only on the previous term. Let's see. Let's just write a form based on first, well, yeah, let's just write based on the previous term. Sorry. So this is a really easy one to write. Most, fourth graders could tell me the recursive form for the one we just talked about, because they could all tell me we started at what? And then to find the next term, what did we do? Yes, so we took the previous term and added 3. Okay, so they wouldn't write it this way, but they would understand if we used the words. To find any term, you take the previous term and you add the difference. So you always have to tell me the first term equals and then a sub n equals a sub n minus 1 plus the difference, right? And the difference can be negative, for sure. It can be a fraction, it can be a decimal. So this is the generic, that's what recursive looks like. You always have to tell me the first term because the sequence depends on where you start. And then you just tell me to get to the next one, I take the last one and I add whatever. This is really easy to work with as long as you know the one before it, right? If I ask for the 53rd term and I only tell you the first, this is not so easy to work with. All right, is just starting practice here. What's the common, is it arithmetic? First of all, how do you decide that? Yes, and you always take one and subtract the previous. So negative 30 minus negative 24 would be negative 6. Is that what they kept doing? Okay, so they subtracted 6, subtracted 6, subtracted 6. We're all good? So you say, yes, it's arithmetic, and the difference is negative 6. Does it make sense that we didn't do negative 24 minus negative 30 because we'd get positive 6? And then they're not adding 6. All right. Fractions. Any ideas how to deal with this? Okay, 4/3 minus negative 1/3 would be what? Okay, did they add 5/3 again? Well, if we're at 4/3 and we add 5/3, we get 9/3. That would be 3, right? If we're at 9/3, did they add 5/3 again to get to 14/3? Okay, I probably would have rewritten this as 9/3 right here because it would have helped my little pea brain. Because then I could have said, oh yeah, that went up 5, this went up 5 more, this went up 5 more. So you have to remember though that each of those was thirds. So the difference is 5/3. So it's yes, D equals 5/3. Sorry, that was a really weird D. You could have used your calculator. You could have said 14/3 minus 3. 3 minus 4/3, 4/3 minus negative 1/3, and you would have got the same decimal every time to show that it was a constant. Okay. Yes or no?
No.
Here they subtracted 1. Here they subtracted 4. Here they subtracted 18. Okay. It's just a no, right? All right, this is telling us it must be arithmetic. We're to find the common difference in the next 3 terms. I'm going to skip to 8. 7's too easy. So can we tell what the common difference is here? How would we determine that real easy if you wanted to use your calculator? Take any term minus the previous term, as long as it's arithmetic, will give you the difference. So yes, negative 8/3 minus negative 2 on your calculator gives you what? Negative 2/3, because this would be 6/3. Or if we wrote this as thirds, this would be negative 6/3. If we did this times 3, top and bottom, it would be negative 12/3. Does that help some of you see what's happening? The top is just going down by 2. So the D is negative 2/3. Okay, I need the next, what does it say, 3 terms though? So we were at negative 12/3. If we take away 2 more, we'll be at, yes. And then 2 more would be, and 2 more would be negative 18/3, which would be negative 6. So there's the next 3 terms. Obviously, number 7 would have been much easier, but same concept. Find the common difference and the 52nd term. Okay, that's very specific. Which one do you want to do? Okay, what is the common difference here? Yep, negative 5 minus the previous term would be negative 8. That seem right? Double check yourself. Okay, so anybody remember how to find the 52nd term easily? Yeah, if we take a sub 52, we just made n 52, right? So the first term, the formula looks like this. If you're, what's the first term? 3 plus the difference, which is negative 8, times, yeah, 52 minus 1, if you want to write it that way in your notes, but it is 51 times a negative 8 plus 3. I'm getting negative 405, but you with the calculator would be better. Okay, so that was a sub 52. Questions? Seem okay? I know they've been doing this stuff in college algebra as well. Can I skip 10? Everybody good? All right, find the explicit formula. So basically this is do the same thing. Let's do 12 real fast. A sub n equals, what's the first term? 30 plus the difference is negative 8, right? N minus 1. This is an explicit formula. You leave the n in. It's based on the term number. Okay? Explicit. Ooh, sorry. I hate when it does that. Explicit means it has an n in it. It's based on the term number. So over here, we're going to say you can find any term if I take the first term of 9/10 and add, well, the difference would be 12/5 minus 9/10. I probably would rewrite this. If you double that, you get what, guys? 24 over 10. Double this, you get 54 over 10. So it was going up by 15 over 10, right? Which is what? Somebody try typing this. Yeah, this is 1.5. So you could use 1.5. I would probably put 3/2. In theory, you could put 15 over 10, right? And then n minus 1. Yes? No? We okay? All right, given the explicit formula for an arithmetic sequence, find the common difference in the first 4 terms. All right, so what does n stand for again? N equals the term number. So how are we going to find the first term? It's actually not 197. Because to find the first term, you put in what? 1. So what is the first term? 197 minus 200 once is negative 3. The second term, you can put in a 2. 197 minus 200 twice should be I think so. A sub 3 is going to be yep, and a sub 4 is negative 603. How can I tell that from up here? Well, I just want to clarify what happened is they took the first term and they added the difference n minus 1 times. But what did they do to this equation? Well, they did some algebra. Do you see what I'm talking about, guys? It's kind of all hidden in here because they did the algebra, okay? They distributed and combined like terms. But the difference is still what's multiplying by n, so the difference is still here. But we can't tell what the first term is until we put a 1 in. Any question? So do we need to talk about this one real quick? Just tell me the first term. Put in a 1, and you get 14.4, and then what are you going to keep adding? Ooh, yeah, the difference is 2.3. It did ask in the directions for us to find the difference, which I didn't write on the last one. You're going to keep adding 2.3. Oh my goodness. 16.7, did I add that right? 18 would be 19. 21.3, how did I do for the next 4 terms? Okay. 13, we should have somewhere written that the difference was negative 200. Everybody good? Questions? Okay. Let's pick one of these. Which one do you want to do? 16. It says, given the recursive formula, okay, what does this mean in words? Because this is how you have to write a recursive formula. Nice. First term is negative 2.6. And then what does this one mean? Previous term. This means previous term. You got to be good at saying that when you see that n minus 1. The previous term, and then you do what? Yeah, that's the difference. Or you subtract 1.1. So what did it say? The difference, okay, d equals negative 1.1. But then they wanted the first 4 terms. This is even easier in my brain. You just write negative 2.6. They gave us the first one, right? That counts, guys. Sometimes on a quiz, someone will think that doesn't count as the first term, but it does. That's why it's called a sub 1. Then if you subtract 1.1, negative 3.7, 4.8, 5.9, how did I do? Is that right, guys? Okay. Any questions? You get what recursive is? Do you need me to go back and do 15? All right, so now we have to find the recursive formula. This is really easy. You have to tell me what, though. You always have to tell me. And again, Hofbauer doesn't rule the world. If she was queen of math, I would say, tell me the first term first. But they always tell me the first term at the end for some reason. But somewhere you got to tell me the first term. A sub 1 is 16, and over here, a sub 1 is 3/2. Then the recursive formula always goes a sub n equals a sub n minus 1 plus some difference, where a sub 1 is, and they give you some number. Okay, so a sub n equals the previous term. What are we doing on this one? Subtract 9. So what's this one going to look like? Anybody know? Say that vocabulary for me. A sub n equals a sub n minus 1. Don't be afraid to say it. And what are we doing? Yes, taking away a half, right? This was 1.5, 1, 1/2, 0.
Matter?
No, when I'm grading, it doesn't matter to me. Yeah, you can definitely state the first term out front. Just always remember there's two parts to this. The book will generally state it at the end. And sometimes there'll be something weird. It'll say like where n is greater than 1 or something. So you can't go backwards and find the negative 12th term. They'll just say something like that, but you don't have to say that. I'm good. All right, given explicit for find the recursive. What do we need to have recursive? We need two parts. This, right? How do we find the first term, though, given this form? It's not shown there. We have to do what? Yeah, we have to put in n equals 1. Okay, put in n equals 1. That's why it says here a sub 1. So when I put in n equals 1, I get negative 26 plus 30 once would just be what? 4. So the first term is 4. Now, we could put in a 2 to see what happens. If we put in a 2, we get 60 plus this would be negative 34. No, positive 34. Yes? So it goes 4, 34, dot, dot, dot. So what is the difference? Okay, it's always what's multiplied here. So the difference is 30. So how do we write this? Everybody okay? Gotta have both of those parts. Do we need to do the other one or not? Okay. All right, find the term named in the problem and the explicit formula. I would do that in the opposite order. If we write the explicit formula, what will we have to put into it to find the 30th term? Let's put in n equals 30, right? Okay, so the explicit formula looks like this. Okay, help me put numbers in. Equals negative 33 plus, what are we adding every time? The difference is be negative 25 minus negative 33 would be positive 8. I'm okay if you leave it like that on a quiz. If you look at the answer key, it's probably going to do this. Which would simplify down to what, negative 41? Did I add that right, guys? Okay. So this is like a simplified form, but I'm okay with either one of those. You can leave it like this when it says explicit. I'm good with that. We still haven't found the 30th term, though. You can put a 30 in here or down in here. So it would be negative 33 plus 8 times 30 minus 1, or 29. What did you get? Positive 199. Oh dear, that wasn't what I meant to do. Can you see it, guys? I need a little bit better. One more of those or not? Okay. All right, given two terms, and they're not the first and second term, find the term named in the problem. Okay. This is going to take a little thinking. If we went from the 16th to the 34th term, how many differences did we add? Did we? We got to figure that out. Let's do an easy one first. 2, 4, 6, 8, 10, 12. Okay? So we'll say the second term here, third, fourth, fifth, sixth term here. How many differences did we add? 2, 3, 4, 5, 6. Okay. We added a difference once, twice, 3 times, 4 times, right? So we did add 4 differences to get to this. So how many differences did we add here? 6 minus 2 was 4, right? So 34 minus 16 is 18. Yep. That's because when you tell me you want the 10th term from the first term, 10 minus 1 is 9, right? So you add 9 differences. So you just subtract the term numbers. Okay, so 338 was a term, and then we added 18 differences to get to 689. So let's write up here ourselves a little note. Term number minus term number, other term number, equals the number of differences. Okay, so 34 minus 16 gave us 18, and that meant 18 differences were added here. How do we work backwards and find the difference then? Okay, so subtract 338 means 18 differences was a total of 351. Divide by 18, the difference is 19.5. Okay. Why is that helpful? Oh, thank you. That's the kind of thing I do all the time. 698, thank you, minus 338, 360, which is just 20, right? Okay, guys, thanks. All right, so how do I find the 27th term? What? Yes. Okay, this is the 16th term. How many more differences do we need to add to get to the 27th term? 11. Okay. So we take 338 plus the difference of 20 11 times, and that'll give us term 27. So this was the 16th term plus the difference 11 times would give us the 27th term. What do you get? Okay, quick check. From the 27th to the 34th, how many more differences should you add? From 27 to 34, 7 more differences, right? So if you did 558 plus 7 20s, do you get to 698? Anybody checking? Okay. So do you see what I did? I just checked that from 16 to 27, we got this term. And then I checked that from there, adding the differences, we'd still get back to that term. Okay, so this was a sub 27. That was kind of a tricky little math problem, huh? All right, should we try this one? Need one more of these, maybe? Okay, we're almost done. Okay, so from the 20th to the 32nd term, the 20th term plus how many differences? 12 times would give us the 32nd term, right? So let's put those numbers in. negative 1862 plus the difference 12 times got me to negative 3062. So I just kind of wrote it in symbols and then put the numbers in. So 12 differences is 12,000? 1,200, I mean? Negative 1,200. Yes? So D is negative 100? That hurt my brain. I don't know why. It shouldn't have. All right. How do we find the 36th term then? Well, I would just start with the 20th term, right? And add how many differences this time to get to the 32nd? 16 differences. So we had negative 1862 and we added negative 100 16 times. Negative 3462. Someone fix me. No? What'd I do? It should be 4 more terms after this, right, guys? So 400 more below that, because we're subtracting 100. Oh my, totally. Got more of these or something different? Oh, they want the explicit formula. I tell you what, this is another challenge because to have the explicit formula, we need the first term. We can go backwards though, right? We're good. So how many differences? So the 36th term was the 20th term plus the difference 16 times. So 7019 equals, you guys solve, find the difference. Anybody get 200 for D? Okay. Now how are we going to go backwards and find the first term? Because the explicit formula looks like this. A sub n equals A sub 1 plus D n minus 1. We know D, and we're going to leave n in, but we need 1. Okay, so we have the 20th term would be the first term plus the difference n minus 1, or 19 times. Just putting it in words, okay? So what's the 20th term? So that was the first term, but we added 200 19 times. So some of you can just think it out like Keaton did. He said, we're going to take that 3819 and subtract 219 times. What are we going to get? Yeah, this is 3800. So A sub 1 is just 19. So we got to go back and finish writing the whole sequence here. A sub n equals, what was the first term? Plus n minus 1. And I'm okay with that right there. The book, if you were checking, or the worksheet even probably, would distribute that. So you'd get 19 plus 200, n minus 200, 19 minus 200, negative 181. Someone check me. Is that right? 19 minus 200? Okay. So this is what they would probably have, but I'm okay with this one too. Want to try the last one? How many differences were added? Negative 73 plus 20, yeah, 24 differences got us to negative 217. I'm skipping the in between here. What is that? Negative 144. So then we divide and get negative 6. Okay, so the 16th term was the first term plus the difference how many times? 15 times. So this would be negative 73 equals the first term plus negative 90, I think. If I add 90 over there, what do I get, guys? Is it 17 or no? I'm going to double check this when I'm done here, but I got 17, negative 6, and minus 1. Let's see. So I would put in a 15 with negative 90. Yeah, I think that's right, to get 39. All right, so on worksheet 2, there's lots of practice. Do as much as you need, but the minimum that is assigned is the circled problems, okay?
Okay.
How many of you thinking you probably, if you're a junior, thinking you need to ace this next summative on this stuff? Okay, so practice. Remediation is in the bin. I realize some of you, I have a CM okay, but how is that going to hold